Okay, so welcome to our Chapter 5 test review. This test is set up like the ones that we've done in the past. You're going to have 10 multiple choice and some free response. That will be weighted 50-50. So we do that because that is what you do on the AP exam in the spring, and that's really what we're all trying to do, is get you ready for that. So let's go through these and see what you need to know for the test on Thursday. All right. Now, these multiple choice questions are not the level of difficulty that I like. These are pretty easy. Hopefully we'll all get at least 8 of them right. So in D number 1, it's just a basic idea about probability. Let's say, for instance, I roll a die. Let's pick a good number, 360 times. That seems kind of random. Uh, how many threes do you think you'd have? Well, let's see. What's the probability of getting a 3? If it's a fair die, it'd be 1 over 6. And so then, if I do that 360 times, I would expect to have 63s. Wow, those numbers worked out really swell. Alright, but that's just the idea. It's a pretty simple question. Everybody should start with at least a 5, right? Because that's 55. Yeah, that's right. Alright. To successfully answer number 2, you're going to have to know some of the properties of probability models, or I like to use the word distribution. Remember that for any probability, we'll call event A, it's going to be between 0 and 1, inclusive. Yikes. I did not major in typing in school. Alright, and so what it means, it's inclusive. In other words, it's going to be either less than or equal to 1 or greater than or equal to 0. So the probability of an event can be 0, the probability of it can be 1, but it can't be above 1 and it can't be negative. Now, for a model or a distribution, the sum of those probabilities should add up to 1. So, like if I'm talking about flipping a coin, alright, what are the probabilities? 1 over 2, 1 over 2, what do they add up to? Hey, 1. If you're looking at a fair die, what are the probabilities? Dot, 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 dot. Those are all 1 over 6s. And I add that up to 6 over 6, or 1. Alright, so know that the sum of the probabilities of a series of events or models for a distribution is always going to be 1. Never negative. Now, don't get tricked by something like this. This would be awful if this happened to you. If I had the probabilities 1, 2, 3, and 4 like this. Well, that sums to 1, Mr. Rogers, so it must be okay. But remember, that's negative, so that's why it's not good. Alright. That should be another one that you do really well on. Problems 3 and 4 deal with you reading a two-way table and answering some questions. So let's make up a two-way table. So let's do one of these, one of those. Alright, and I don't know, male, female sound good. And how about positive or negative? Maybe we're doing blood types. That's good, that's total. And let's make up friendly numbers for arithmetic, because that's always nice. Alright, and then just be prepared to answer any question from that. So you might get probability that you select a male. Well, that's 10 over 20 or 1 over 2. Or the probability that it's a positive blood type. 14 over 20, we'll simplify that to 7 over 10. Right? It could be more complicated. It could be the probability that you're male given you're negative. Alright, so I'm only looking at these guys because I know it's negative, and there are 2 males that are negative out of the 6 negative people. So it'd be 1 over 3. And so you just have to be prepared to answer a couple of questions like that. Oh, rats mix up a 3. Let's fix it real fast. There we go. Alright, now to be successful on number 5, you need to be able to distinguish between and understand the concepts of mutually exclusive and independence. Now, mutually exclusive means they cannot happen at the same time. So if I looked at this two-way table over here and was asked to describe mutually exclusive things, being male and female cannot occur at the same time. Being positive and negative cannot occur at the same time. Those would be mutually exclusive events. Now, independence speaks to probability. So remember, if the probability of A is equal to the probability of A given B's occurred, and the probability of B, see how I say that? Is equal to the probability of B given A occurs. Alright, then the two things are independent. So they might not be mutually exclusive, but they're independent. So if I talked about the probabilities, oh no, how do I do that? That's a good trick. If we want to decide between positive and male being independent, well, let's see, what's the probability of being a male? Probability of being a male is 10 over 20, which is 1 over 2. What's the probability of being male given you're positive? Well, let's see. I'm given positive. I'm only looking at these guys. So that's 8 over 14. And that is 4 over 7. While it's awfully darn close, those two are not the same. So they're not independent. So you'll have to do something like that for number 5. There we go. He's sad that he's not independent. Oh, let's see. We'll go back to the old full screen. When you use 6, it's just a probability problem. And I guess it's really a classic probability problem. You're just calculating the probability of an event. So if I tell you there are 20 red chips and there are twice as many blue chips, what's the probability that you draw a blue? Oh goodness, so if there's 20 red and there's twice as many blue, that's 40, which means I must have 60 total. So the probability of blue would be 40 over 60, which is 2 over 3. So you have some sort of probability question like that. 7, the same thing. 7 is just sort of a classic probability problem. This class successful. Alright. Good for me. So remember successive events, you're probably using the multiplication rule. Alright, the addition rule is for ORs. Probably I draw red or blue. And then successive events would be probably I draw red and probably I draw another red. Alright, and 8 is a conditional probability problem. So remember a conditional probability, that the probability that A and B occurs is the probability of A times the probability of B given A occurs. So this is definitely a formula that you want to be familiar with when you take this test on Thursday, because there's going to be another part later in the free response where you might have to manipulate this equation and realize that the probability of B given A is equal to the probability of A and B divided by the probability of A. Right? It's just a little algebra. It just looks funny because we have all the cool symbols. Right? But I just solved for this. The way I got it by itself was that. But for H, you have a conditional probability problem. 9 is probably one of the harder ones, and it deals with both conditional probability, so what I just showed you, and mutually exclusive and independence, and how those can all work together. So this is one that you might have a little trouble with. I can't really go into too much detail without giving you the question, which I don't want to do. All right. But think about different ways you can manipulate those things. 10 is a probability question, which, I mean, the chapter is probability, so I could probably safely stop saying that. And I'll give you a hint for this one. Compliments are good things. Alright, so you can do this without compliments, but just a little hint. Might make your life easier. Alright, let's move into that free response section. Hope everyone's enjoying the Christmas music. Okay, so the free response question, the law of large numbers comes up. You want to interpret in context. You will want to be able to find the probability of successive events. Now, if you think back to section 1, which seems like it was a really long time ago, because it was a really long time ago, it was way before Thanksgiving. Remember, we had a lot of simulation design. So you will have to be able to describe setting up a simulation using a random digit table, and then actually carry it out. There is a section of a random number table printed on your test. So flip to the back of your book, practice doing that. I guess if we had to very quickly do one, let me see, I'm going to generate some random numbers on my calculator. You can't see it, but really I am. Math, probability. I'm just going to do a random number. And then write those digits down. So the digits that came up for me are 8, 2, 0, 9, 3, 6, 0, 1. Alright, these were just random numbers to my calculator, so I'll pretend they're my random number table. Now they're big, you can really read them. So let's say that I know the probability of yes is 1 over, let's do 3. I know the probability of yes is 1 over 3. If I have 4 people surveyed, I want the probability that all 4 are yes. So if the probability is 1 over 3, then I might assign, let's get some order in here. Then I might assign 0 as yes, 1 and 2 as no, disregard others, and sample 4 at a time, recording number of times all were yes. That might be one way to design it. You could think of another. So if I did that, and I carried it out with this, hopefully I have enough to do at least one. Let's see how it would work. Alright, so I'm going to do red pin and cross out the 8. I disregarded him. And then I have a no. I have a yes. I'm disregarding. I have a yes. I'm disregarding. I have a yes. And why I put a yes over this, I have no idea. That would be disregarded. Alright. And so I have to keep going to this next person, who's a no. So I sampled 4. I've got 2 yeses, but I was going for 4 yeses. So this would be a failure. So in my trials, if I had success and fail, this would be a fail. And then I would do, repeated trials carrying on the table. Like I wouldn't start over in the same one and go, okay, now I'm going to do the trial. Because of course I'd get the same thing. So then I would start at the next set of random numbers and keep going on from there. Alright, that's what you have to do. Do a simulation design and then carry it out with a random number table. Finally, there we go. You get to have fun with Venn diagrams. That means you get to draw one for an event. So let's say I have 30 people that love tacos, 20 people that love pizza, 5 that love both, and 60 samples. Let's draw a Venn diagram for this. So here's my universe of the 60 sample people. There's a taco circle. And there's a pizza circle. And then I designate them with a T and a P in there. Now I do have this thing here that says that 5 love both. So that tells me I need to intersect. And my numbers, and this is where somebody's going to make a mistake. This is 5. There are 30 that like tacos, but 5 of them are already hanging out in this intersection. So that means I have 25 here. And same with pizza, I've got 20 total, but 5 are already hanging out in the intersection. So I've got 15 here. So that's 30, 45 people out of 60. So that means I have 15 people that like neither pizzas nor tacos. Alright? Not even kidding. Somebody's going to do this. I'll write it in red so we don't do it. But somebody's going to invariably do 5. 30, 20, 5. Alright? And then those people are going to get wrong. So don't be those people. And now you're going to have to answer questions about that. So let's answer some. What would be the probability that someone selected likes tacos or pizza? So that could be 30 over 60 plus 20 over 60, and then take out the overlap. So that's 50, 45 over 60. That's 3 over 40, you and me, or 0.75. It could be the probability of tacos and pizzas. So that would be 5 over 60, which is 1 over 12 to you and me. Which is 0.083 repeating. So that part shouldn't be too bad. Your final question on the test on Thursday is a probability question. And it just deals with the multiplication rule. Whoops, there's an L in multiplication. Multiplication rule. That was a neat trick. I have no idea how I made it highlight like that. I should practice. Nope, that's not it. Wow, anyway. So just remember that the probability of A and B is equal to the probability of A, this is all new, times the probability of B given A has occurred. I've got to figure this trick out. Alright, so that's everything that's on your test. You're going to have to do the practice test for your homework tonight. Tonight being Tuesday night. I most likely won't be in at all on Wednesday, maybe for just a little bit. But if you can find me, you're welcome to check your answers. If you have a question about one, you can email me, and I will answer. Gotta figure out how to turn that highlighter on, nifty trick. Alright, thanks for watching.